Hi girls, so tomorrow we're going to learn about how to find the area in between two curves. And you can see here I've got an example lined up already. We're going to do the area enclosed by the curve y equals x plus 1 and that parabola x squared minus x minus 2. So as always, well, as very often, first thing I want to do is I want to draw a graph. So I'll start by drawing the line x plus 1. And then I'll draw the parabola x squared minus x minus 2. That's x minus 2x plus 1. Oops, sorry, don't know what I did there. So, I don't actually care what the y-intercept is, but it's obviously minus 2. So now I can draw the curve like so. And so I get that's minus 1 there, and that there is 2. And what I want to do is I want to find this whole area in here. Now if I go back to my very first lesson on finding the area of under curves, we think about rectangles, and the rectangle in this circumstance is this one here, where we've still got width, you know, dx or delta x, and we've got height, and this time the height is y minus y. We might say y1 minus y2, where the top one is y1 and the bottom one is y2. Okay, so and hopefully that's fairly obvious. So we're going to have to find an expression for y1 minus 2 by taking f and g and subtracting the parabola from the line, because the line is always on top. But before we do that, we're going to have an integral, and we need our limits. Now, the first limit is easy. It's minus 1, right, coming from the point where they meet. But for the second limit, we need to do some algebra. So we start by setting the equations equal to each other, because we're finding the x-coordinate, and we move everything to one side. I like to keep my x squareds positive wherever possible. And because I already know one of my roots is x plus 1, factorising this is quite easy. So I get that x equals minus 1 or 3. And that gives me enough information to do my integral. Now I want you to notice that when I did this step here, I subtracted, if this is my y2 and this is my y1, right, the two sides, I subtracted one from the other. So in fact, what you can always do is you can always just integrate that highlighted line there. And I'll show you what to do when you're undoubtedly wrong 50% of the time. Right, so the area, and you'll see what I mean by wrong in a second, is from minus 1 to 3, from minus 1 to 3, x squared minus 2x minus 3 dx which equals x cubed on 3 minus x squared minus 3x between 3 and minus 1. And I won't bore you with the substitution, but if you do this properly, you will get 10 and 2/3. You actually get minus 10 and 2/3 units squared. Now the reason you got 10 and 2/3 minus and not 10 and 2/3 positive is because over here, when I subtracted, I did the parabola minus the line when I moved everything over to that side. But if you look back at the first slide, the line is always bigger than the parabola. So I should have actually done the line minus the parabola. And you can fix that by cheating, effectively. By going all the way back to the front, and you just chuck a minus in front everywhere and change the minus here to a plus. And that's a fairly valid way to do it if you happen to make a mistake in an exam situation. It's also accepted that you're allowed to just put absolute value signs around you're working, and then just change it to a plus at the end, because you know you've done the right thing. Alright, there's a couple other small issues that we'll take care of tomorrow, but for now that's all I need you to really worry about. There's a nice new photo of Maud getting ready to peck the camera, so I'd like you to think about that a little bit more tonight, and then I'll talk to you more about it tomorrow. Thanks, girl.